Containers within an operating system are considerably more separate than processes. They have different file systems and different file system states, but they are still using the same kernel and the host operating system. And that's one of the reasons a container can start really fast. It doesn't have to boot an operating system from scratch. So if you got a bug in your kernel here, that means that your containers, which are meant to be isolated from each other, might have some bug through the kernel that lets them influence each other. So sometimes even more isolation is in order. A virtual machine abstracts away the hardware instead of abstracting the operating system. So that means a virtual machine is a process in some host operating system, but inside that process, it thinks it has its own operating system running on its own piece of hardware. A virtual machine, in other words, is a kind of interpreter that runs a CPU, and it can do that inside a process in another operating system. Since it is restarting at the CPU level, then the operating system that you run in a virtual machine, Windows say, does not have to be the same as the operating system running inside the host. It doesn't need to use the same kind of kernel or system calls or so on. From a security perspective, this can also be more secure because the virtual machine has to simulate the processor. If it does something wrong, it might leak things in a way that lets you get back out to the enclosing operating system and so on. But what this virtual machine is emulating is very simple sort of CPU level instructions, so it's harder to get those wrong in a way that allows escapes out of the virtual machine. Even within the context of virtual machines, there are two kinds of virtual machines. A virtual machine that uses emulation really is a direct interpreter of machine code, so there's no reason that on an x86 CPU you have to interpret x86 machine code. It could be ARM or PowerPC or whatever. And an example of a virtual machine that uses emulation is QEMU. QEMU has backends, that is, interpreters, for lots of different processors, and it can run on lots of different machines. And so it's a way of running as if you're on any other kind of machine, on any kind of machine. Virtualization relies on the CPUs in the virtual machine and the host machine being the same, and it takes advantage of the hardware to be the interpreter directly. To provide any sort of sandboxing, it still needs to intercept certain things, especially system calls and other things related to virtual memory, but it can take advantage of running directly on the processor to be typically considerably faster. VirtualBox, for example, relies completely on virtualization and doesn't do emulation. If you use Docker on macOS, then you will be running Linux operating systems inside of macOS, which clearly is not the same thing as using the same kernel. So Docker on macOS actually uses a virtual machine layer to run Linux operating systems, and since it's doing that kind of virtualization anyway, it can use QEMU to do emulation. On an ARM64 Mac, for example, you can still run x86 or PowerPC virtual machines and so on. So it looks like containers. You get the same sort of management of images and containers, but with emulation underneath it.